So, Mr. Aryaman, we have this cuboid of dimension 1 meter, 3 meter, 2 meter. This is a cuboid that we have. This cuboid is made up of iron. This is a symbol of iron. Now, roughly the density of iron is 8,000 kg per meter cube. And I'm considering G, acceleration due to gravity, to be 10 meter per second square. The question is how to find the weight of this cuboid. Mr. Aryaman, what do you suggest?
So first, we would find the mass. So
Okay.
mass equals to density into G.
Density into G.
Yeah.
So which formula is this, sir?
I mean, sorry, mass equals to density into volume.
Density into volume.
Yeah, sorry. And so our volume will be 1 into 3 into 2 meter cube. So that'll be 6 meter cube. So 8,000 into 6 meter cube.
How do I find the volume of this cuboid?
We do L into B into H. So that's 1 into 3 into 1 into 2 into 3. So that we'll get 6.
6 kya, Mr. Aryaman?
6 meter cube.
Yes, sir. You need to specify the units or you will be losing half mark for every unit that you miss. So this is the volume of the cuboid, 6 meter cube.
Yes.
Now this 6 meter cube will come here.
Yeah.
So what will be the mass, sir?
So mass will be 4.8 into 10 raised to 5.
So I'll keep it easy. It will be 48,000 kgs. Do we agree?
Yes, sir.
Mr. Aryaman, you need to take care. If you don't mention the units, you will be losing half mark.
Okay.
Now I have got the mass. How do I find the weight?
Mass into G. So that will be 48,000 kgs into 10 m per s square.
Meter per second square.
10 meter per second square. So we will get 480,000. So that's 480,000 meter per second square.
Yes, sir. What is the SI unit of weight?
Oh, sorry, it'll be Newton, sir.
Sir, please do not write this as kg meter per second square.
Okay, sir.
Because you have been told that the unit of weight is Newton. Any doubt about this?
Sorry?
Any doubt about this numerical?
No, sir.
And of course, what your teacher might ask is that she needs the final answer in scientific notation. And then of course, you'll have to write this as
4.8 into 10 raised to 5.
4.8 into 10 raised to 5 Newton. She might ask this. And of course, another thing that you need to take care is, or she might have already discussed in the class, what is the G that she wants you to take. Usually it is mentioned in the paper.
Okay, sir.
But if it is not mentioned in the paper and she has told you in the class that it has to be taken as 9.8 meter per second square, then you need to take it as 9.8 meter per second square. But there are times, I don't know, there are times when, just to simplify the calculations, usually in paper they will write G as 10 meter per second square. Mr. Aryaman, have you understood what I'm saying?
Yes, sir.
See, please try to understand. Till now, the only volumes that have been discussed with you are of cube and cuboid, because they are very simple. I'm sorry. They are very simple figures. So this can be L. So this volume would be L cube and this would be LBH. Mr. Aryaman, have you understood?
Yes, sir.
But then there are these objects whose volume is very well known. So for example, this is a sphere, this is a cylinder. So these are regular solids. I think in class 9th, I think, yeah, most probably in class 9th, you will find volume of these regular solids. Have you understood what I'm saying?
Yes, sir.
There is a cone also. So in the next class, they will share the volume of these also. Now, once you have the volume of these, now these formulas would remain the same. Only the volume would be dependent upon the whatever you are using. Are you using a sphere? Are you using a cylinder? Or are you using a cone? Sharman, is it clear?
Yes, sir.
But then you will have another issue if you take care of an irregular solid. So, for example, if I take a stone, if I take a stone and I want to take the say I want to find the density of the stone, then how do I find the density of the stone? This is irregular, so there is no formula for this. Mr. Arman, have you understood the problem?
Yes, sir.
Then how do I find the density?
So,
This has been discussed in your class. Yeah.
So we take like a container
Shabash.
in which there is liquid.
Shabash.
So now we will let's say fill the liquid till
Shabash.
10 kg. I forgot the unit for density.
See, the experiment is very simple. So I can find the volume of a stone using this beaker.
Yes, sir.
There are scale in it. So how do I find? Say for
So,
example, yeah, Mr.
when
Anand.
you put the stone in, then it'll rise. So the difference is your volume.
Sure. So the simple thing that you do is let us assume that the water, before you start the experiment, the water is filled till here and the level is, say, for example, let us say 100 ml. Have you understood?
Yes, sir.
Now, when you dip the stone in it, the stone will sink here. And let us assume that the volume rises to 125 ml. ml is milliliters. Have you
Yes,
understood? So this rise in the volume of water, the reason for the rise is stone.
Yes, sir.
So the volume of stone would be
25.
25 ml. Do we agree to this?
Yes, sir.
So I have got the volume of the solid. Volume of solid. The volume of solid is 25 ml. Then I can use my lab equipment to find the mass. I'll put the stone here and I will find the mass. Mr. Aravind, do you agree?
Yes, sir.
Let us assume, just to take a figure, it is 100 gram. Yeah. So density is equal to
Mass upon volume.
mass upon volume. Mass would be 100 gram. Volume would be 25 ml. And your final answer is 4 gram per.
Per ml.
Have you understood?
Yes, sir.
Of course, there is unit conversion which is required, which I'm not getting into right now.
Okay, sir.
Understand? The only thing that you need to remember when you are converting the units is very simple thing that you need to remember, that 1 liter is equal to 1000 centimeter cube. Mr. Araman, any doubt?
No doubt, sir.
Another very simple conversion is 1000 ml is equal to 1000 centimeter cube. You can note this down because if you have to convert, then you will require this information. Therefore, 1 ml is equal to 1 centimeter cube. Mr. Araman, any doubt?
No doubt, sir.
So, actually, what we have discussed in now is what we have discussed till now is volume of a regular object. Regular object is an object for which the volume formula is there. Volume formula is there. Usually till class 8, they will give you cube and cuboid problem only, because you are not conversant with the volume of sphere, of cylinder, of cone. Usually they will avoid giving this.
Okay, sir.
So one question might be that they might ask you the regular object. They might give you a regular object which is a cube or a cuboid, and you will be required to find the density. Yeah. The second thing that they might do is they will give you a experimental setup, and from there you'll have to find the volume of an irregular object. Mr. Arman, any doubt? Mr. Arman, any doubt?
No doubt, sir.
So usually they'll give you experimental setup. Usually these kind of class question again are asked in 9th and 10th class. But just to give you an idea, they might give you a experimental setup where they will tell you that this is the volume rise. Whatever be the volume rise would be the volume of the solid. Then using this balance, electronic balance, you may find the mass of the solid. And then using the formula of density, gram per ml, and to complicate the matters, if they really want to complicate the matter, what they might ask you is ki whatever is the final answer, they want the final answer of density in kg per meter cube. Have you understood what I'm saying?
Yes, sir.
And then your conversions should be good. Your conversions should be good. Now, usually this convergence is usually a chapter which is done in maths. So whenever we do that chapter, we'll be repeating these conversions again. Mr. Arman, have you understood?
Yes, sir.
So this is the whole approach. I think your teacher has given the formula for sphere, cylinder, and cone, but personally, I feel there is a very less probability that she might ask any question from this, because in 8th class they might avoid. Have you understood? But cube and cuboid, there's a very high probability that they might ask. Star, any doubt?
No doubt, sir.
Okay.